Welcome, curious minds. Today, we're embarking on a deep dive into something you see every single day, but perhaps rarely truly see. The optical wonders of our atmosphere. Forget just looking at the sky. We're going to try and understand how it looks the way it does. We've got a fascinating stack of material today, packed with insights, from scientific definitions right through to some historical puzzles. Our mission, to unpack the magic behind everything, from the blue sky above to those, well, elusive fairy tale castles you might glimpse on the horizon.
And what's really fascinating here is how seemingly simple observations, like the color of a cloud, they reveal these incredibly complex interactions of light and matter. We'll be connecting the dots between light, air, and your perception, giving you hopefully a whole new lens to view the world around you.
Yeah, get ready for some truly eye-opening moments as we explore the optical characteristics of Earth's atmosphere and, well, the stunning phenomena it produces. Okay, let's unpack this. So let's start with a foundational question. What exactly is atmospheric optics?
Simply put, it's the study of the optical characteristics of the atmosphere and its processes. How light behaves in the air, basically. You might also hear the term meteorological optics, which specifically focuses on patterns visible with the naked eye. While the terms are sometimes used interchangeably, we're really looking at how the atmosphere's optical properties create this huge range of visual phenomena we experience.
Right. So what does this all mean for us, the observer? It means everything from why the sky is blue to those, wild illusions we sometimes see.
Exactly. It underpins so much of what we just take for granted visually.
Okay, so one of the most fundamental questions then, why is the sky blue?
Well, this blue color is primarily due to something called Rayleigh scattering. This process, it scatters more higher frequency, shorter wavelength blue light into your eye than other colors. Like tiny air molecules are just better at bouncing blue light around.
Okay, that makes sense. And what about those stunning sunsets and sunrises then, when the sky turns fiery red or orange?
Here's where it gets really interesting. When the sun is low, its light travels through a much, much thicker slice of atmosphere. So the longer wavelength red light is scattered less than blue light over that distance. It allows the red light to reach your eye while most of the blue light is scattered out of your line of sight. That explains the reddish hue.
You also mentioned other colors in the sky, like glowing dusks and dawns.
Yes, these are often influenced by additional particulate matter in the sky, things like dust or pollution. These particles scatter different colors at varying angles. We even see this effect quite dramatically sometimes, like when dust from the Sahara moves into the southeastern United States. It can change the sky from blue to a kind of whitish appearance and really intensify the red sunsets.
Wow. And it impacts air quality too, I imagine.
Oh, definitely. It's not just a visual thing.
Okay, moving from the sky to the clouds themselves. What do their colors tell us?
Well, the color of a cloud provides significant clues about its internal composition, its density, really. Dense, deep tropospheric clouds, they typically appear white. That's due to highlight reflectance, maybe 70% to 95%. The tiny water particles are just so densely packed that sunlight is reflected out before it can penetrate very deeply at all.
But clouds aren't always bright white. We see them in shades of gray, too. What's happening there?
Exactly. So as clouds mature, the water droplets can combine, they get bigger, creating larger spaces between them. This allows light to penetrate further in. And if the cloud is large enough or deep enough, a percentage of light gets absorbed rather than reflected back out. That leads to that whole range of colors, from white to dark gray, or even black sometimes.
Just like seeing farther in heavy rain than in heavy fog, you mentioned.
Yeah, that's a decent analogy. Larger drops, more space for light to potentially get through or be absorbed deeper inside.
Now, I've heard that some cloud colors, like green, can indicate specific weather conditions. Is that true?
This raises an important question, yeah. Why do certain colors appear? Bluish-gray in a cloud, for instance, results from light scattering within it. Shorter wavelengths, like blue and green, are more easily scattered by rain-sized droplets. And you're right, a cumulonimbus cloud appearing green is often seen as a significant sign of a severe thunderstorm, capable of heavy rain, hail, maybe even tornadoes.
But why green?
Well, the exact cause is still debated, actually, but it's thought to be maybe a combination of reddened sunlight, like from a low sun angle passing through very optically thick clouds, with the blue light scattered out, leaving a kind of greenish tint. Maybe large ice or water particles play a role, too.
Fascinating. And what about those dramatic red, orange, and pink clouds we often see at sunrise or sunset?
Those colors are almost exclusively tied to sunrise and sunset conditions. When the sun's angle to the horizon is less than, say, 10%, The sunlight becomes so reddened by the long path through the atmosphere, that scattering and refraction we talked about, that only colors with a reddish hue are really visible. The clouds themselves aren't changing color, they're just reflecting those long, unscattered rays of sunlight. It's like shining a red spotlight on a white sheet.
Right, they're just showing the color of the light hitting them.
Precisely.
Okay, beyond colors, our atmosphere creates some truly mind-bending illusions. Let's talk about the moon illusion. Why does the moon seem so much larger on the horizon?
The moon illusion. What's fascinating here is the history of trying to explain it. For a long time, people thought it was atmospheric magnification. But back in the 11th century, Ibn al-Haytham argued something quite different. He said vision occurs in the brain, and our personal experience influences perception. He proposed that our judgment of an object's distance relies on having an uninterrupted sequence of intervening bodies.
Intervening bodies. Like
Yeah.
what?
Like trees, buildings, the landscape itself. For the horizon moon, you see all those objects between you and the horizon. This makes your brain perceive it as being very far away, and therefore, logically, it must be large. An overhead moon, though, it lacks these intervening distance cues. It's just up there in the empty sky, so your brain judges it as closer and thus smaller.
So it's more about how our brain interprets distance cues rather than an actual physical change in the moon size or atmospheric lensing.
Exactly. Ibn al-Haytham redefined it as a perceived rather than a real enlargement, a psychological effect. This explanation eventually superseded Ptolemy's older refraction theory in the 17th century. But even today, after, over a century of research by vision scientists, as Ross and Plug concluded in 2002, no single theory has emerged victorious for the moon illusion.
Wow. So it's still a bit of a mystery.
It's a wonderful example of just how complex our perception really is.
Now let's talk about mirages, those shimmering images we sometimes see, especially on hot days.
Right. Mirages are real optical phenomena. They're not hallucinations. What happens is that light rays get bent when they pass through air layers with different temperatures, different densities. This changes the air's refractive index. This bending displaces or distorts the images of distant objects or even the sky.
So the shimmering water on a hot road.
That's typically an inferior mirage. The light from the blue sky above is bent upwards as it passes through the hot, less dense air near the road surface. So you see the sky image below where the sky should be, and your brain interprets that shimmering blue as a reflection from water. But it is real light rays reaching your eye just from an unexpected direction. You can photograph a mirage.
You mentioned a few specific types of mirages.
Yes, mirages can be inferior, like the road mirage where the image appears lower, or superior where the image appears higher than the actual object. And then there's the most complex, the fata morgana. We also have things like green flashes and green rays.
Green flashes.
Yeah, brief optical phenomena seen right at sunrise or sunset, usually just a green spot visible above the sun for a second or two, caused by refraction splitting the sunlight slightly. It can even happen with the moon or bright planets sometimes.
Okay, tell me more about this fata morgana. The name itself sounds like something out of a storybook.
It absolutely does. Fata morgana comes from Italian. It refers to the Arthurian sorceress Morgan Le Fay. Old legends said these mirages were fairy castles conjured up in the air to lure sailors to their doom.
Wow, so what causes them physically?
It's a very complex form of superior mirage. It occurs when light rays are strongly bent as they pass through air layers of very different temperatures. Specifically, you need a steep thermal inversion.
The thermal inversion.
Yeah, where warmer air rests over significantly cooler, denser air near the surface. This creates what's called an atmospheric duct.
Oh, it's like a natural lens in the air.
That's a great analogy, a very unstable, complex lens. This lens produces a rapidly changing series of images, some inverted, so upside down, some erect, so right side up, often with zones that are compressed and others that are stretched vertically. It makes distant objects like islands, ships, or coastlines appear tremendously distorted, almost unrecognizable, constantly shifting.
Incredible. And what about the Novaya Zemlya effect? That sounds quite dramatic, too.
The Novaya Zemlya effect is another fascinating polar mirage. It's also caused by high refraction of sunlight between these atmospheric thermoclines, these sharp temperature layers. It basically gives the impression that the sun is rising earlier or setting later than it actually should, sometimes by quite a bit.
Like how much earlier?
Potentially days in extreme polar conditions. It can also make the sun appear distorted, like as a line or a square shape, sometimes called the rectangular sun, or even flattened hourglass shapes. This effect requires sunlight to literally bend around the Earth's curvature for at least 400 kilometers. You're seeing the sun when it's geometrically well below the horizon.
And that it's named after.
It was first recorded by Gerrit de Veer during Willem Barents's ill-fated Arctic expedition in the 1590s near the Novaya Zemlya archipelago, hence the name.
Amazing stories tied to these phenomena. Okay, let's shift our focus now to those beautiful arcs and rings we sometimes see around the sun or moon. Yeah. Halos, right?
Exactly, halos. These are optical phenomena produced when light from the sun or moon interacts with ice crystals suspended in the atmosphere. They create these colored or white arcs, rings, or bright spots.
Where do these ice crystals usually form?
They often form in high-level clouds like cirrus or cirrostratus clouds way up in the upper troposphere, or sometimes, in very cold weather, they can form near the ground as diamond dust, tiny ice crystals glittering in the air.
How do these tiny ice crystals create such precise, large patterns?
It all comes down to the geometry of the ice crystals. They're typically hexagonal, six-sided. The specific shape and orientation of these crystals are key. They act like millions of tiny prisms and mirrors. They refract, bend, and reflect sunlight between their faces, sending shafts of light in very particular directions relative to the sun and the observer.
So that explains the specific angles.
Precisely. That's why you see preferred angular distances, like the common 22-degree halo and the rarer 46-degree halo, for these circular phenomena. The angles are determined by the crystal shapes and the path light takes through them.
And people used to use them to predict weather.
Yes, their presence, especially the 22-degree halo associated with thickening cirrostratus, has historically been used in weather lore as a sign of an approaching warm front, and often rain within 24 to 48 hours.
And what are sundogs? They seem to be a common example of a halo.
Sundogs, or parhelia, are indeed a common type of halo. They appear as two subtly colored, bright spots, one on each side of the sun. They're usually about 22 degrees away horizontally and at the same elevation as the sun.
What causes those specifically?
They're typically caused by plate-shaped hexagonal ice crystals. As these tiny plates sink through the air, they tend to orient themselves horizontally like little frisbees fluttering down. This alignment means they refract sunlight sideways, creating those bright spots to the left and right.
And the colors?
They're usually reddish closest to the sun, gradually fading through orange and yellow to blue or violet farther out, though often the colors overlap quite a bit and look rather muted, mostly whitish with maybe a red inner edge.
Okay, let's move to something else equally stunning. The glory. What's that?
The glory is a beautiful optical phenomenon, but it involves water droplets, not ice crystals like halos. It appears like an iconic saint's halo, but it's seen around the shadow of the observer's head, projected onto a cloud or fog bank.
Around your own shadow.
Yes. It's produced by light being backscattered, essentially reflected back towards the light source, the sun, by a cloud of uniformly sized water droplets. The physics is actually quite complex, involving a combination of diffraction, reflection, and refraction, maybe even surface waves on the droplets.
So it's similar to a halo in being circular rings, but uses water droplets instead of ice crystals.
Exactly. And its appearance is different too. A glory has multiple colored rings, typically with red on the outermost ring and blue or violet on the innermost. And its angular size is much smaller than a rainbow or a halo, usually ranging from maybe 5 to 20 degrees from the center point, which is your shadow's head.
And you can only see it under specific conditions.
Right. You can only see it when you are directly between the sun and the cloud of refracting water droplets. The sun needs to be behind you. This is why it's very commonly observed from an airplane surrounding the aircraft's shadow on clouds below. It's often called the glory of the violet for that reason.
I've seen that. Never knew what it was called. Okay, and finally, the ultimate optical spectacle. The rainbow.
The rainbow. Probably the most well-known atmospheric optical phenomenon. It's essentially a narrow, multicolored, semicircular arc. It's caused by a combination of internal reflection and dispersive refraction of white light within millions of raindrops.
Dispersive refraction.
Yeah, that just means that different colors of light bend by slightly different amounts when they enter or leave the water drop. Water acts like a prism, splitting the white sunlight into its constituent colors. And then there's reflection inside the drop.
And it always appears opposite the sun.
Always. You need the sun behind you and the rain in front of you. For you, an observer on the ground, the visible arc depends on the sun's height. It's a full semicircle when the sun is right at the horizon. As the sun gets higher, the rainbow gets lower, and it actually disappears completely when the sun is more than about 42 degrees above the horizon.
So you can't see a midday rainbow, usually.
Not unless you're looking down on the raindrops, maybe from an airplane or a mountaintop. Then you can sometimes see the full circle.
I've definitely seen double rainbows before. How do those work?
Right, double rainbows are quite common. The brighter one is the primary bow. That has red on the outside and blue-violet on the inside. It results from sunlight entering a raindrop, reflecting once off the back surface and then exiting. This produces an arc with an angular size of about 40 to 42 degrees from the anti-solar point, the point opposite the sun. The fainter secondary bow appears about 10 degrees outside the primary one. It's created by light undergoing two internal reflections inside each raindrop before exiting.
And the colors are reversed.
Exactly. Because of the second reflection, the colors are reversed, with blue-violet on the outside and red on the inside. It spans an angular size of about 50.5 to 54 degrees.
And there's that dark band between them, isn't there? I always noticed that.
Yes. That region between a double rainbow is noticeably darker than the sky inside the primary bow or outside the secondary bow. It's known as Alexander's dark band, named after Alexander of Aphrodisias, who first described it around 200 AD.
Why is it dark?
It's dark because, due to the angles involved in single and double reflections, very little sunlight is scattered back towards the observer from raindrops within that specific angular region between the bows. Light is scattered into the bows, but not between them.
Fascinating. So what about the specific colors we see in a rainbow? Is there really 7 distinct colors? ROYG, BIV.
Well, this raises that important question again about perception versus physical reality. A rainbow actually spans a continuous spectrum of colors. There are no hard boundaries. The distinct bands we perceive, including the classic 7 red, orange, yellow, green, blue, indigo, and violet, that's really an artifact of human color vision and how our language and culture categorize that continuous spectrum.
So a camera would see it differently.
A black and white photograph, for example, would just show a smooth gradation of intensity, brightest in the red and fading through the spectrum. Maybe brightest again in the secondary bow if it's visible. No distinct bands at all.
That really changes how you think about it. Okay, let's touch on a few other striking visual effects, like crepuscular rays. I love seeing those.
Crepuscular rays, yeah, they're beautiful. Those near-parallel shafts of sunlight that appear to diverge outwards from the sun's position, often when it's below the horizon or hidden by clouds or mountains.
But they're actually parallel.
Right. They're essentially parallel beams of sunlight. The divergence is just an effect of linear perspective, like looking down long, parallel railway tracks. They seem to spread out from the sun and converge towards the point opposite the sun.
What makes them visible?
They occur when objects like mountain peaks, or more commonly clouds, partially shadow the sun's rays. The rays themselves become visible because airborne compounds, dust, haze, water droplets scatter the sunlight through diffraction, reflection, and scattering. They're most common near sunrise and sunset.
And what about anti-crepuscular rays?
Oh,
Are
yeah.
they related?
Yes, they're essentially the other end of crepuscular rays. While parallel in reality, anti-crepuscular rays are sometimes visible in the sky in the direction opposite the sun. They appear to converge again at the anti-solar point, near the distant horizon. So if you see crepuscular rays radiating from the sunset, turn around 180 degrees, and you might see these fainter rays seemingly converging on the opposite horizon. Same phenomenon, just viewed from the other end of the perspective lines.
Very cool. Finally, let's briefly touch on atmospheric refraction and diffraction again, just to recap their main roles.
Sure. Atmospheric refraction is fundamental. It's the bending of light as it passes through air layers of different densities, usually caused by temperature or pressure variations. It generally influences the apparent position of celestial objects, usually making them appear slightly higher in the sky than they actually are. This is most pronounced near the horizon.
Which is important for astronomy and navigation.
Absolutely. Astronomers and navigators need to account for it, and they try to observe objects when they're higher in the sky to minimize these refractive effects. Atmospheric diffraction, on the other hand, is more about the slight bending or spreading of light waves as they pass the edge of an object or through very small openings. In the atmosphere, it's a visual effect caused when sunlight is bent by tiny particles suspended in the air like water droplets or ice crystals. It contributes to phenomena like the glory or the corona around the sun or moon sometimes.
Got it. Refraction changes direction due to density. Diffraction is bending around edges or particles.
That's a good summary, yeah. Both play crucial roles in many of the effects we've discussed.
Wow, what a deep dive. My head is full of light rays bending and scattering now. We've journeyed from the basics of atmospheric optics all the way to the stunning complexity of rainbows, mirages, halos. I feel like I now really understand how Rayleigh scattering paints our sky blue, how those tiny ice crystals craft intricate halos, and why the moon seems to play tricks on our eyes. It's fascinating.
It really is. We've seen how our atmosphere isn't just, empty space. It's this incredibly dynamic canvas, constantly bending, scattering, reflecting light to create these truly breathtaking phenomena, from the uh, fairy tale castles of Fata Morgana to that elusive green flash at sunset. These are real optical occurrences, shaped by physics, and sometimes, like with the moon illusion, shaped significantly by our own perception, too.
Yeah, this deep dive really reveals how much scientific wonder is packed into just everyday observation, things you see all the time. The next time you look up, you'll not only see the beauty, but hopefully you'll have a better sense of the incredible science making it happen.
So what stands out to you from all this? Maybe think about how understanding these phenomena might change the way you appreciate the next sunrise or sunset, or the next time you see a rainbow, or even just a cloud. Will you see it differently now, knowing a bit more about the light's journey to your eyes?
Definitely something to ponder. We hope you enjoyed this journey into atmospheric optics. Keep looking up and keep being curious.
Welcome to the Deep Dive. Today we are diving deep, really deep, into one of the world's most incredible rivers, the Yangtze.
It truly is immense. Just think about it. Nearly 6,400 kilometers long.
Right, stretching all the way to the East China Sea. That makes it the longest river in Eurasia and the third longest river globally.
Exactly. But its size is just one part of the story. The area it drains, its basin, covers a fifth of China's land.
A fifth. That's enormous.
And it's home to almost a third of the country's population. So you can imagine the economic weight it carries.
Yeah, I saw a figure. The Yangtze Delta generates something like 20% of China's entire GDP.
That's right, 20%. It's an absolute economic engine.
And of course, you can't talk about the Yangtze without mentioning the Three Gorges Dam.
The biggest hydroelectric power station on Earth, sitting right there on the river.
It's quite something. So for this deep dive, we're drawing on a really comprehensive Wikipedia source. The idea is to give you, our listeners, a solid understanding of this vital waterway, its history, its challenges, its future.
We want to take you on that journey from, where it starts, all its different names.
Through its massive historical impact and then into the modern era, the environmental pressures, but also, importantly, the conservation efforts.
It's a story that kind of mirrors the wider global environmental situation in many ways. You see the problems, but you also see people trying to find solutions.
Definitely. So let's start with the geography. That sheer scale we mentioned, third longest in the world, 6,374 kilometers. Just wrap your head around that.
Where it begins is actually quite interesting, too. There was a bit of a debate, or maybe a correction, about its true source.
Oh, what was that?
Well, traditionally, people pointed to the Tuatu tributary up at Jeladandong Mountain.
Okay.
But then, relatively recently, in the late 20th century, hydrologists identified the actual longest source, hydrologically speaking. It's Jury Hill, at the head of the Dam Core tributary.
Jury Hill. So where's that relative to the old source?
It's about 365 kilometers southeast. So a pretty significant shift in understanding where this massive river truly begins.
Wow, okay. So even something as basic as where does the river start wasn't fully settled until fairly recently. That's fascinating.
And from that starting point, high up in the Tenggula Mountains on the Tibetan Plateau,
Wow.
what a journey it takes.
Incredible drop in elevation too, right? Over its first couple thousand kilometers or so.
Oh, absolutely. It drops something like 5,200 meters in the first 2,600 kilometers. It carves through these deep valleys.
Passing through all those major provinces, Qinghai, Sichuan, Hubei, eventually reaching Shanghai in the sea.
Yeah, Yunnan, Hunan, Jiangxi, Anhui, Jiangsu. It touches so much of China.
Okay, so we have this immense river carving its way across the country. A river that significant must have picked up a few names along the way.
Oh, definitely. The official Mandarin name, Changjiang, is pretty straightforward. It just means long river.
Long river, makes sense.
But yeah, locally and for different sections, there are many other names. Upstream, for a long stretch, it's the Jinsha River.
Jinsha, what does that mean?
Gold Sands River. And even further up, near the source, it's called the Tongqian River.
Tomtian.
Leading to heaven.
That's beautiful. Leading to Heaven River. And there are even more local ones, right? Depending on the province.
Exactly. Like in the Sichuan and Chongqing, you might hear Changjiang, the Sichuan River.
Okay.
In Hubei, it's the Jingjiang, or Jing River. In Anhui, Miantang. It reflects how people interacted with their specific part of the river.
So where does the name we use most often in English, Yangtze, actually come from? It doesn't sound like Changjiang.
No, it doesn't. And this is a great example of historical, well, confusion, I guess. Yangtze comes from Yangtze,
Yangzheng.
which was a local name specifically for a lower section of the river near the city of Yangzhou.
Just one section.
Yeah, probably named after an old ferry crossing there, Yangtze. So when early European traders and missionaries arrived in that area
They heard the local name for that bit of the river.
and mistakenly assumed it applied to the entire river, and the name just stuck in the West.
That's incredible. A local name for a ferry crossing ends up being the global name for one of the world's longest rivers because of an early misunderstanding.
It really shows you how these things happen. And there was another English name used for a while too, wasn't there?
Ah, yes, the Blue River, which is kind of ironic.
Very ironic.
Eh.
Because the Yangtze is famously not blue. It carries a huge amount of sediment, making it quite muddy, yellowish-brown, really.
So Blue River didn't really catch on, unsurprisingly.
No, it fell out of favor, didn't match reality, and had no link to the Chinese names either.
Okay, from names to deep history, what about the river's origins and geological time?
Well, there's some debate among geologists, as there often is with these ancient formations. But a common theory dates its formation back to maybe 45 million years ago, during the Eocene epoch.
45 million years, that's some serious deep time.
Absolutely. And in terms of human history, its significance is just immense and goes way back. We have evidence of human activity in the Three Gorges area dating back 27,000 years.
27,000 years ago.
Yeah. And by around the 5th millennium BC, so 7,000 years ago, the lower Yangtze was already a major population center. Think early rice farming cultures, like the Hemudu and Majiabang cultures.
So a cradle of agriculture, really. Different from the Yellow River Basin further north.
Very much so, initially. The lower Yangtze developed distinct cultures, sometimes grouped under the term Yu peoples. They had different traditions, things like short hair, tattoos, living in bamboo settlements. Quite different from the nascent Chinese culture developing along the Yellow River.
And geographically, it often acted as a boundary, right? A dividing line between North and South China.
A major one. It was incredibly difficult to cross for much of history, which naturally made it a strategic political and military border.
Leading to some famous battles, I imagine.
Oh, absolutely. Probably the most famous is the Battle of Red Cliffs in 208 AD, a pivotal moment in the Three Kingdoms period. Naval warfare right there on the Yangtze.
Wow. Any others?
Well, much later, in 1161 AD, you had the Battle of Kaishi. Song Dynasty soldiers were using trebuchets, basically giant catapults on their warships, to launch bombs made of lime and sulfur at the Jurchen invaders' ships.
Right there on the river.
Bomb-throwing catapults on ships. Okay, that's vivid. But beyond conflict, it became crucial for the economy.
Hugely important, especially from the Han Dynasty onwards. Irrigation was key. Systems like the ancient Dujiangyan project, northwest of Chengdu, made the surrounding plains incredibly fertile and productive for agriculture.
Dujiangyan. That one is still functioning today, isn't it? Parts of it?
Amazingly, yes. A testament to ancient engineering. And this agricultural wealth, combined with trade along the river, meant that by the Song Dynasty, the Yangtze region, particularly the lower part near the delta, was arguably the wealthiest part of China.
And that continued.
Yes, right through later dynasties. During the Qing Dynasty, the Jiangyan region, that lower Yangtze area, provided something like a third to half of the entire nation's tax revenue.
Incredible. And didn't the Grand Canal play a role in connecting it? Yes. The Grand Canal linked the Yangtze to the Yellow River and northern China, further cementing its role as the economic artery of the country.
So let's jump forward now into the era that started to change navigation on the river dramatically, the age of steam.
Right. And the very beginning was, shall we say, eventful. You had the Jardine.
The Jardine, the first steamship on the river, built for a British company.
Exactly. Jardine Matheson.
Yeah.
Built in 1835. But the Chinese authorities were not thrilled.
How did they react?
They saw it as this strange, potentially dangerous fire ship. When it tried to steam up the Canton River, they actually fired upon it.
Fired on the first steamship. Wow.
Yeah. And that incident, the Jardine incident, is actually cited as one of the contributing factors that pushed Lord Palmerston in Britain towards declaring the First Opium War.
So the arrival of steam power was immediately tangled up in international tensions and conflict.
Pretty much from day one. And even with steam, navigating parts of the Yangtze, especially the upper river, was incredibly difficult.
You mean the section through the gorges, like from Yichang up to Chongqing?
Precisely. You've got the sheer volume of water coming down, especially with the Himalayan snowmelt in summer.
Yeah.
You've got the narrow gorges concentrating the flow, creating vicious cross-currents, whirlpools, eddies. It was treacherous.
And before steam, how did they even get boats upstream against that current?
It was brutal work. They used trackers, teams of sometimes 70 or 80 men, literally harnessed to the boats with thick ropes, hauling them inch by inch against the current along narrow cliff paths.
Unbelievable labor. So making commercial steam navigation viable up there must have been a huge challenge.
A massive challenge. And the person really credited with cracking it was Captain Samuel Cornell Plant.
Captain Plant, what did he do?
He was working in the early 20th century. He didn't just sail the ships. He designed special steamers suited for the rapids. He systematically installed navigational markers along the dangerous stretches. He trained the first generation of Chinese pilots for steam navigation on the upper river.
So he really built the system.
He really did. He even supervised the use of explosives to remove some of the worst navigational hazards. His contribution was considered so significant that after his death, a unique memorial, a 50-foot granite obelisk, was erected for him in Xintan, a collective effort by the Chinese and foreign communities. Very rare for a Westerner.
A lasting legacy. Now, thinking about crossing the river itself, it's hard to picture now with all the bridges, but for a long time there just weren't any, right?
Astonishingly few for such a major river. Until 1957, believe it or not, there were 0 bridges across the main stretch of the Yangtze, from Yibin down to Shanghai.
0. So how did people cross?
Ferries. That was it. For thousands of kilometers, your only option was a ferry.
That must have been a huge bottleneck for transport and communication.
Absolutely. Which makes the modern era of bridge building even more remarkable. The first big one was the Wuhan Yangtze River Bridge, finished in '57.
With Soviet help, wasn't it?
Yes, during that period of closer Sino-Soviet ties.
Yeah.
Then came the Nanjing Yangtze River Bridge in 1968, a major feat of Chinese engineering at the time.
And then things really took off later.
Oh yeah, especially from the 1990s onwards, the pace of bridge construction just exploded. Now you have dozens, including some of the world's longest suspension bridges and cable-stayed bridges spanning the Yangtze. It completely transformed connectivity.
It really reshaped the landscape. And the river also played a part in, well, political symbolism too, didn't it? With Mao Zedong.
Ah, yes. Mao's famous swims in the Yangtze. He did several, but the ones in 1956 and especially 1966 were huge public spectacles.
Why 66 specifically?
That was right at the start of the Cultural Revolution. Swimming the river was a very public way for him, already in his 70s, to project an image of health, strength, and enduring revolutionary vigor to the entire nation. It was powerful political theater.
Using the river itself as a stage. And that spirit of taking on the river, it continues in different ways. You mentioned an adventurer.
Right, Krols Klivdal, a Danish adventurer. In 2002, after apparently 12 years of planning and getting permissions, he became the first foreigner since the Communist Revolution in 1949 to navigate the entire length of the river.
Wow, that must have been quite an undertaking. A symbol of a changing China, perhaps. More open.
Perhaps. A sign of cautious reopening and allowing that kind of international engagement with such a vital, symbolic waterway.
Okay, so we've seen the history, the navigation, but we need to turn to a more serious side now. The Yangtze as a river under immense pressure. Let's talk about the hydrology, the floods, the environmental challenges.
Yeah, this is crucial. The Yangtze floodplain is naturally prone to flooding, especially during the summer monsoon season. Millions upon millions of people live there, relying on extensive systems of dikes for protection.
And when those defenses fail or are overwhelmed, the results can be catastrophic.
Absolutely devastating. The 1931 floods are often cited as one of the deadliest natural disasters in recorded human history. The death toll estimates vary wildly, but range from maybe 145,000 up to staggering figures like 3.7 or even 4 million people.
4 million. It's almost impossible to comprehend that scale of loss.
It truly is. And there were other terrible floods later, too. 1954 is another major one. 1998 caused huge damage. And even as recently as 2016, there were very severe floods.
And there was that recent sort of counterintuitive theory about the heavy rains in 2020 linking them to the pandemic lockdowns.
Yes, that's a really interesting piece of research. 2020 saw the heaviest rainfall since 1961. The theory suggests that the abrupt reduction in air pollution, greenhouse gases, and aerosols caused by the COVID-19 economic slowdown actually altered atmospheric conditions and contributed to those intense monsoon rains.
So cleaning the air temporarily might have inadvertently worsened the floods. A stark reminder of how complex these systems are.
Exactly. It shows these deep, sometimes unexpected connections. And it highlights the broader issue. The river system has been profoundly altered and degraded over decades.
How so? What are the main drivers of that degradation?
Well, starting mainly in the 1950s, there was a massive push for dam building and constructing dikes. This cut off over 100 natural lakes from the main river channel.
Cut them off completely. What did that do?
It destroyed their function as natural flood buffers, which ironically increased flood risk downstream. And it blocked migration routes for countless fish species, devastating their populations.
And then there's pollution.
Huge amounts. Industrial pollution has been a major problem for decades. Agricultural runoff fertilizers, pesticides washing into the river, siltation from deforestation and land use changes, loss of wetlands. The list goes on.
And plastic pollution too, right? I read the Yangtze is a major source of ocean plastic.
The major source, sadly. Studies estimate the Yangtze carries more plastic waste into the ocean than any other river system in the world. It's estimated that just 10 rivers globally carry about 90% of the plastic reaching the oceans, and the Yangtze is #1 on that list.
That's a shocking statistic, and all this pressure must have had a terrible impact on the river's unique wildlife.
It's led to a genuine biodiversity crisis. The most tragic example is probably the Yangtze River dolphin, the baiji.
Go on.
It's considered functionally extinct. There hasn't been a confirmed sighting since 2004, despite intensive searches. It's likely the first large vertebrate driven to extinction by human activity in over 50 years. A real tragedy.
Oh, that's heartbreaking. What else is threatened?
The Chinese paddlefish, another ancient and unique species, was declared extinct just recently. The Chinese alligator is critically endangered, surviving mostly in small protected reserves. The narrow-ridged finless porpoise, the Yangtze's only remaining cetacean, is also critically endangered. The Yangtze sturgeon is hanging on by a thread.
And the dams play a big role in this.
A huge role, especially for migratory fish. Dams like the Three Gorges and many others create what scientists call an impassable iron barrier, completely blocking fish from reaching their spawning grounds upstream. It shatters their life cycles.
It sounds incredibly bleak, but you mentioned earlier there were also signs of hope, conservation efforts. Is anything being done to turn this around?
Yes, thankfully. It's not all doom and gloom. There have been some really significant efforts, particularly in the last couple of decades. One key initiative started back in 2002.
What was that?
It was a pilot program to start reconnecting some of those lakes that had been cut off from the river. They started with a couple of lakes, like Zhangdu Lake and Bedang Lake, installing sluice gates to allow water and fish to move between the river and the lakes again.
Reconnecting the lakes? Did it work?
Remarkably well, actually. The results were pretty immediate and positive. Water quality in the lakes improved. Fish populations rebounded quickly as fish could migrate in and out, replenishing the genetic stock.
Any other benefits?
Yes, it helped with flood control, restoring some of that natural buffering capacity. And interestingly, it even had economic benefits for local communities. Farmers around the reconnected lakes shifted from intensive aquaculture using artificial feed to harvesting naturally replenished fish stocks. Their incomes actually increased by about 30% because their input costs went way down.
Wow, so ecological restoration led directly to economic improvement. That's a powerful combination.
It really is. And the success of that pilot wasn't ignored.
Did it spread?
It did. Other provincial governments saw the results and started similar projects. It led to the creation of the Yangtze Forum in 2005, which was a big step getting all 13 provinces along the river together to try and coordinate management from the source all the way down to the sea.
A more holistic approach.
Exactly. And then, critically, in 2006, the national government stepped in. China's Ministry of Agriculture made lake reconnection an official national policy.
That's huge. What came out of that?
It led to the establishment of a whole network of protected areas along the river wetlands reserves. We're talking about 40 protected areas covering something like 16,500 square kilometers.
And has that helped the endangered species?
Evidence suggests it has. Populations of at least 47 threatened species have increased within these protected zones, including the critically endangered Yangtze alligator. And restoring wetlands has also been vital for securing clean drinking water sources, even for massive cities like Shanghai downstream.
That's genuinely hopeful news. Are there any other major conservation measures?
Yes, a really big one came into effect in January 2020.
What was that?
A complete 10-year fishing ban on the entire main stem of the Yangtze, all its major tributaries and the connected lakes.
A 10-year ban on the whole river system?
The whole thing, all natural waterways. It's a drastic measure, aimed squarely at letting fish populations recover and protecting the overall aquatic biodiversity. It's a massive commitment.
It really is. It shows a serious shift in priorities, balancing economic use with ecological health.
Definitely. It's a long-term investment in the river's future.
So we've covered a lot of ground. From its immense scale and debated source, its many names reflecting local life.
Through millennia of history, as a cultural cradle, a political boundary, an economic engine,
The challenges of steam navigation, the modern era of bridges, and then the really stark environmental pressures, the floods, the pollution, the heartbreaking species loss.
but ending on that note of significant large-scale conservation efforts, reconnecting lakes, establishing protected areas, that huge fishing ban.
It really paints the Yangtze not just as this mighty river, but as you said earlier, a living case study. It shows the incredible impact, both negative and potentially positive, that humanity can have on these massive natural systems.
It embodies that duality, a cradle of civilization that also became a prime example of environmental degradation.
And now, maybe, hopefully, a model for regeneration and finding a better balance. So as we wrap up this deep dive, maybe the thought to leave you, our listener, with is this. Reflecting on the Yangtze's story, this epic journey of creation, exploitation, now attempted healing. What does it tell us about our own relationship with the powerful natural forces that shape our planet? What lessons about destruction, but also about our capacity for change and restoration, stand out most to you from this river's incredible ongoing story? The name Illuminati, just saying it, it conjures up images, doesn't it?
Oh,
So, shadowy figures, pulling strings, secret plots for global control, hidden agendas.
Yep.
It's a word you hear whispered online or, sensationalized in movies. It's instantly recognized almost everywhere.
It really is remarkable how one name can gather such a dense layer of mystique and fear sometimes.
Yeah, fear too.
It's become one of maybe the most enduring conspiracy theories out there.
Absolutely. So, okay, let's unpack this for you today. We're doing a deep dive into the real Illuminati.
Right, the historical one.
Exactly. Not the Hollywood version, not the internet rabbit holes, but the actual 18th century secret society from Bavaria.
Mm-hmm.
Our mission here is to strip away all that myth and get to the fascinating historical truth, and we're drawing directly from the sources you've shared with us.
We'll look at what they actually set out to do, who they really were, and trace the real story of how they rose and fell.
It's quite a journey.
It really is.
Yeah.
And it shows so clearly how historical facts can just morph into these huge, fantastical legends.
So by the end of this, you'll walk away truly well-informed. You'll get the history, sure, but also why this particular group became such fertile ground for, well, centuries of conspiracy stuff.
Okay, so where do we start?
We have to start with the setting. Paint a picture of 18th century Bavaria.
Right, the context.
Imagine a society where religious institutions and the state had this huge, often intertwined grip on daily life, real control.
That's the world Adam Weishaupt steps into. He started as a professor, canon law, and practical philosophy, University of Ingolstadt, 1773.
And the key thing here, wasn't he the only non-clerical professor at a place basically run by Jesuits?
Pretty much. I mean, the Pope had officially dissolved the Jesuit order, but in Ingolstadt, they still held a lot of sway. Controlled university finances, the curriculum.
Sounds like a recipe for conflict. I mean,
Yeah.
Jesuits trying to block non-clerical staff, especially anyone leaning towards liberal ideas.
Oh, definitely. The friction was intense, and this constant battle against that entrenched power. It made Weishaupt deeply anti-clerical, profoundly so.
Okay.
He got convinced that the only way to effectively spread Enlightenment ideas, the Aufklärung, was secretly, through a society shielded from all that opposition he faced daily.
A clandestine network.
Exactly.
So he had this vision. He thought about joining the Freemasons first,
Right.
but decided against it.
Yeah, he checked it out, but he found it, well, too expensive for one thing.
Huh. Practical concern.
And maybe more importantly, not quite open to his specific, pretty radical ideas for reform. He wanted something he could shape completely.
So he took matters into his own hands.
We did. May 1st, 1776. Founds his own society with just 4 students. That's it.
4 students. And the initial name was Bund der Perfectibilisten.
Covenant of perfectibility. Rolls right off the tongue, doesn't it?
Not really. Apparently it sounded too strained.
Yeah, so they rebranded.
That-
April 1778, it becomes the Illuminate Norden Order of Illuminati. Much better ring to it.
He apparently considered calling it the B Order, too. Almost a fun little footnote.
He did. Imagine the conspiracy theories about bees. Anyway, they went with Illuminati. Owl of Minerva as their symbol. Wisdom, hidden knowledge, makes sense.
And secrecy was key. Aliases. Weishaupt was Spartacus.
Right, and the first students were Ajax, Agathon, Tiberius, and Erasmus Rhododamus. Though poor Erasmus got kicked out later for indolence, laziness, basically.
Even secret societies have HR problems. So what were their stated goals, the official line?
Actually, pretty progressive for the time. Oppose superstition, obscurantism, deliberate ambiguity, religious influence in public life, abuses of state power.
Sounds reasonable.
Their order of the day, written right in their statutes, was, and I'm quoting loosely here, put an end to the machinations of the purveyors of injustice, control them without dominating them.
Control without dominating. Interesting nuance.
Yeah. Early on, the structure was simple. 3 grades: novice, Minerval, illuminated Minerval. The Minerval one apparently had a pretty complex ceremony.
And they spied on each other. A system of mutual espionage.
Well, yeah, sort of monitoring each other's activities, character, ensuring loyalty, making sure everyone stayed true to the ideals.
And recruitment. They were picky.
Very. Favored candidates. Rich, docile meaning compliant, willing to learn, and aged 18 to 30.
And specific exclusions, too, right? Who wasn't welcome.
Right. Explicitly excluded. Jews, pagans, women, monks, and members of other secret societies. Shows they wanted a very specific mold, and maybe were wary of infiltration themselves.
Makes sense.
Initial growth came mainly through Massenhausen, one of the first students. He recruited a key figure, Xavier von Zwack. By late 78, maybe 27 members, across 5 regional commands.
With cool code names like Munich being Athens and Ingolstadt Eleusis.
Exactly. Still small, but organized.
Okay, so they start their own society because Freemasonry wasn't quite right. But then there's a shift. They seem to see Masonry as a tool.
A very pragmatic shift, yeah. Almost like if you can't beat them, infiltrate them. Weishaupt realized building a whole network from scratch was slow going.
So he joins the Masons himself.
Yep. 1777, Lodge Prudence. His stated goal, internally at least, was to learn their rituals, see how they worked, and basically use that knowledge to boost his own order.
Clever. Maybe a bit sneaky.
Definitely strategic. And it worked, didn't it?
Seems like it. They got a warrant from the Grand Lodge of Prussia to start their own lodge in Munich. Theodore of the Good Counsel. March 1779.
And that lodge was, quote, quickly packed with Illuminati. By July, Weishaupt's order was essentially running it.
Wow.
Their next move was independence. They linked up with a lodge in Frankfurt, got Lodge Theodore recognized on its own. And crucially, that meant Lodge Theodore could now create its own daughter lodges.
Okay, that's a huge step. From a local group to potentially a whole network.
Monumental. It really changed the game for them.
And speaking of changing the game, this brings us to a really key figure. Adolf Freiherr Nigg, recruited late 1780.
Yes.
He was already a big deal in Freemasonry, had his own reform ideas. What made him such a game changer for the Illuminati?
Nigg brought what Weishaupt didn't really have. A huge Masonic network, practical smarts, charisma. Weishaupt was more the academic theorist. Nigg knew how to scale things, how to recruit beyond just students.
Turn it from an intellectual circle into something bigger.
Exactly. Broader appeal, wider reach.
Now get this. Nigg was drawn in partly by promises of deep secrets, right? But Weishaupt, being Weishaupt,
Outback, claimed there were these mysterious, most serene superiors pulling the strings.
right, and told Nigg he had to recruit more people before getting access to the higher grades.
Classic Weishaupt. Then, January 1781, the big reveal.
The aha moment. Weishaupt admits the superiors, the ancient origins, all fake, higher degrees, not even written yet.
And Nigg was apparently surprisingly calm.
Why wasn't he furious? Or did he just see an opportunity?
I think the latter. It speaks volumes about Nigg. Instead of feeling tricked, he probably saw, okay, there are no fake bosses, and I get a free hand to create the very degrees I wanted.
So he could shape it his way?
Precisely. Make it much more attractive to the influential Masons he wanted to bring in.
But there were internal problems brewing. Weishaupt, seen as stubborn, dictatorial by the ruling council, the Areopagus.
Yeah, tensions were rising. Interestingly, Nigg often played peacemaker between Weishaupt and the council.
What were the main issues Nigg saw?
2 big ones. First, Too many young, inexperienced students in top spots. Not great for leadership.
Right.
Second, and maybe more critical for growth, the strong anti-religious vibe. Nig knew that would put off a lot of the senior Masons he needed, especially in Protestant areas.
So the plan to spread through Masonry was stalling a bit, because some other Masonic chapter had seniority over their Lodge Theodore.
Exactly, a roadblock. And that's when Nig rolls out his new system of grades, January 1782.
Ah, the structured approach.
Very strategic. 3 classes, designed to integrate with Masonic structures, make it easy to absorb whole lodges. Class 1, the nursery, Novitiate Minerval Illuminatus Minor, basic entry levels.
Then, Class 2, the crucial bit, the Masonic grades, pulling in the standard apprentice, companion, master.
Yep, the Blue Lodge degrees, plus the Scottish novice and Scottish knight, makes it familiar, respectable to existing Masons.
And finally, Class 3, the mysteries. Lesser mysteries, priest, prince, greater mysteries, mage, king.
Though it's pretty likely those top 2, mage and king, the rituals were never actually written. More of a, ultimate goal on paper.
But Nig's strategy worked for recruitment, targeting lodge leaders.
Like gangbusters. Entire lodges started joining. Rapid expansion across central and southern Germany, even into Austria.
The number jumped from a handful to maybe 300 by spring '82, and mostly not students anymore.
Right. Only of the 20 were students. In Munich, they got complete control of Lodge Theodore, cut ties with the Grand Lodge. Big win for independence, proof Niga's system was working.
Okay, summer 1782, the convent of Wilhelmsbad. Sounds important. It was a big meeting for the strict observance Masons who were kind of fading.
Exactly. Declining power. And the Illuminati saw a golden opportunity. Ditfurth represented them, prompted by Nig, aiming to scoop up Masons who weren't keen on all the mysticism floating around.
Did the convent achieve much itself?
Not really. Sort of fizzled. They officially dropped the Templar connection, but kept the fancy titles, oddly. Made the Scottish grade optional. But the key thing for the Illuminati, lodges were now allowed to connect with other systems.
Weakening strict observance.
Right. Open the door wider.
And after Wilhelmsbad, strict observance basically collapses, right? Letting big names like Bode and Prince Charles of Hesse join the Illuminati in early '83.
Yes, major figures came aboard. Weishaupt even proposed this new federation of German Grand Lodges. Focus on the basic 3 degrees, let lodges do their own thing higher up, clearly a vehicle for spreading Illuminism.
But they shot themselves in the foot a bit. They're circular attacking other Masonic groups.
Yeah, that was clumsy. Accusing Royal York of Jesuit influence. Strict observance of being a Stuart plot. It alienated people.
And the irony. Someone else set up a similar non-mystical group, the Eclectic Alliance.
And the Illuminati ended up joining it. Kind of undermined their own grand plan for dominating German Masonry.
So, okay, mass recruitment via Masonry hit snags, but individual recruitment was still beaming, especially in Bavaria.
Yes, Bavaria was fertile ground. Partly a backlash against the ruler, Charles Theodore, who was rolling back liberal reforms. People were unhappy, looking for alternatives.
The order peaks around late '84. Numbers are fuzzy, maybe 650 verified, claims up to 2,500, realistically maybe 1,300.
Somewhere in that ballpark seems likely. But the quality of recruits is what's really striking.
Right, not just students. Professionals, powerful people. Who are we talking about?
Really influential names. Johann Wolfgang von Goethe, the writer. Johann Gottfried Herder, philosopher. Duke Ferdinand of Brunswick-Wolfenbüttel. Karl August, Grand Duke of Saxe-Weimar-Eisenach. High-ranking Austrian officials like Count Brigido, Baron von Swieten. These are major players.
Serious clout. But not everyone was convinced. Some notable rejections.
Oh, yeah. Johann Caspar Lavater, the Swiss poet, apparently questioned using secret means for good ends. Didn't sit right with him.
And Christoph Friedrich Nicolai, the writer.
Found their goals chimeric, unrealistic, and thought their methods were too much like the Jesuits they claimed to oppose. Dangerous.
Interesting pushback. What does that tell us?
Highlights that core tension, right? Progressive goals versus secretive, maybe manipulative methods. For some, the secrecy itself was a red flag, or the methods just didn't justify the ends. Not everyone bought into it.
Then there was the external threat, the Rosicrucians, a rival Masonic group.
Big-time rivals. Pro-monarchy, into mysticism the opposite of the Illuminati's rationalism. Weishaupt tried hard to keep his orders secret from them.
But a clash was inevitable.
Seemed that way. The Prussian Rosicrucians, led by Johann Christoph von Wollner, went on the offensive, accused the Illuminati of atheism, trying to start revolutions.
Serious charges.
Their main lodge, the Three Globes, denounced the Illuminati publicly, called them a sect trying to undermine Christianity, politicized Freemasonry.
And they got inside information.
Yep, an Illuminati informant, Ferdinand Maria Bader, spilled the beans about Lodge Theodore being totally run by Illuminati, exposed them.
Ouch. And internally, things weren't great either. The bickering started up again, Weishaupt versus the Areopagites.
Yeah, Weishaupt seemed to be reverting to his more controlling ways, even apparently slandering people he saw as rivals within the order.
Which leads to this almost unbelievable move. Weishaupt drives out Nig, his best recruiter, organizer, theorist. Why?
It looks like pure power struggle. Weishaupt wanted control back. They clashed over strategy, Weishaupt's hardcore anti-clericalism versus Nig wanting to be more accommodating to recruit powerful Masons. The final straw was apparently a ritual Weishaupt wrote for the priest grade.
What was wrong with it?
Nig thought it was florid and ill-conceived, basically embarrassing and counterproductive. This led to Nig leaving in July 1784.
So what did losing Nig mean, big picture?
Catastrophic. Weishaupt, in forcing him out, basically deprived the order of its best theoretician, recruiter, and apologist. Nig knew how to sell the order, structure it, grow it. Losing him was a massive blow, crippled their ability to expand effectively.
And the final nail in the coffin wasn't just external attacks or internal fights. It was their own members being indiscreet.
Pretty much. The Bavarian Minerval's lower-level members got sloppy, loose talk, boasting about political influence, criticizing the monarchy. The secret order wasn't so secret anymore. Names got out.
And they started getting blamed for things. Anti-religious pamphlets, favoritism.
Exactly. Public alarm grew. The government, under Charles Theodore, saw them as a real threat.
So March 2nd, 1785.
The hammer falls. Charles Theodore bans all secret societies, including the Illuminati. That was the death blow to the Illuminati in Bavaria.
Weishaupt fled.
Yeah. Then the government seized documents in 86 and 87, published them, which, ironically, gave the Illuminati a whole new level of notoriety, even after they were gone.
So the actual historical Illuminati, done, suppressed, finished in Bavaria.
Correct. Operations ceased.
But this is where the story gets weird, where the myth machine kicks into high gear.
Right. Fast forward about 10 years. 1797, 1798. Two books become massive bestsellers. Augustin Barruel's memoirs illustrating the history of Jacobinism.
And John Robison's proofs of a conspiracy.
And these books weren't just saying the Illuminati existed, they were saying they survived and were now an ongoing international conspiracy.
Responsible for the French Revolution.
That was the huge claim. Barruel, who was a Jesuit, pushed this theory, borrowing some ideas from Robison, apparently, that Jews, Freemasons, and the Illuminati were all working together.
To do what?
Demolish monarchies, destroy the Vatican, set up a world republic. It's worth noting Barruel initially focused heavily on Jews as the masterminds, but later backed off republishing that part, reportedly fearing it could incite violence.
Wow. And this idea travels.
Oh, yeah.
Right.
Crosses the Atlantic, lands in the United States. Influential figures like Reverend Jedediah Morse, Timothy Dwight start preaching against the Illuminati.
Linking them to the 1800 U.S. election. That sounds familiar.
Generating real panic, suspicion. It was a whole thing.
So much so, it even shows up in early American Gothic novels, like Ormond or Julia and the Illuminated Baron.
Yep. Direct references to the supposed Illuminati crisis. It shows you, our listener, how fast an idea, even one mostly invented, can just permeate culture, public fear.
The panic died down after the early 1800s.
It did, but the idea resurfaced later, like during the anti-Masonic movement in the 1820s and 30s. The seed was planted.
So what's the legacy then? What's left today? You mentioned modern groups using the name.
Right. There are several fraternal orders around now, or recently, that openly claim they descend from the Bavarian Illuminati. They use the name.
But, and this is the key point for you listening, there's no evidence of any real connection.
Zero verifiable link to the 18th century group. And these modern groups, they haven't exactly amassed huge political power.
It's almost funny, isn't it? Instead of being super secret, many of them actively promote these supposed links to the original Illuminati.
It's like a branding strategy. Use the mystique to attract members.
So the original group did not survive.
Absolutely not. The stuff Barruel and Robison wrote about their later mischief and plottings, considered pure invention by historians.
Yet the modern conspiracy theories persist. The idea that world elites are being controlled and manipulated by a secret society calling itself the Illuminati.
It's incredibly persistent. They get blamed for everything: French Revolution, that 1800 U.S. election, even JFK's assassination. All baseless claims linking back to this imagined ongoing group.
And people point to symbols, right, like the Eye of Providence on the U.S. dollar bill.
Constantly. Used as proof of an Illuminati link to the Founding Fathers, even though that symbol was used long before Weishaupt even started his little group.
So let's wrap this up. What does the whole saga of the Illuminati really tell us?
I think it's just this powerful example, isn't it? How a real, fairly small, short-lived historical group
Can become the seed for these huge, sprawling, incredibly tenacious global conspiracy theories.
Exactly. Theories that completely overshadow the actual history and just keep going generation after generation. It really shows that gap between historical fact and popular myth.
So we've done our deep dive. We saw the real Illuminati start with these Enlightenment goals, maybe noble, definitely ambitious.
Watch them grow, change, get tangled in internal fights and external opposition.
And ultimately get shut down in Bavaria. But then the legend takes over, becomes one of the most pervasive conspiracy theories ever, still shaping culture, still influencing how some people see the world.
Which leaves us with a thought for you, the listener. If this relatively small, brief 18th century society could spark myths this huge, myths that last for centuries,
What does that say about us? About maybe a human need to find hidden patterns, secret hands pulling the strings behind complex world events?
makes you wonder, doesn't it? What other little historical footnotes might have secretly grown into the legends we live with today?